सरफेस केमिस्ट्री। हाँ, स्टार्ट हो गया। It has three parts: adsorption, colloids, and catalysis. AD. So they appear to be different, but at some level they are same. Now the first part, adsorption. The phenomenon of some substances called adsorbate, adsorbent, adsorbent rhyming with solvent. The phenomenon of some substances called adsorbent attracting and subsequently gathering other substances called adsorbates. Onto their surfaces and subsequently gathering is called adsorption. I don't think we need this. What do you mean by surface? Surface up to a depth of 0.1 nanometer, 10 power minus 10 meters, only outermost atomic layer, atom. Coconut charcoal. इधर सामने आ सकते हैं, इतना खाली है. आदत है क्या उधर से देखने डायगोनली. Coconut charcoal, it is an adsorbent. Noble gases, adsorbates, rhyming with solvent, solute. Solvent and solute. So these noble gases, they are adsorbed here. This is called bulk. If a substance goes into the bulk, that is called absorption. Absorption. What is the difference between adsorption and absorption? The substance that is absorbed will come from this and go out from this. It cannot be retained. But the substance that is adsorbed can be retained on the surface and used whenever we require. You can use this again. How? You just heat the substance, it will come out. So adsorption is a surface phenomenon. Surface phenomenon. Now, factors affecting adsorption. What should be your first reaction? Many. There are many factors. Many. One. Pure surfaces. Purer the surface, greater the adsorption, more is absorption. Greater the adsorption. How do you get pure surfaces? Heating in vacuum produce pure surfaces. Heating in vacuum. We have already seen the opposite scenario. A surface poisoned by barium sulfate that acts as a negative catalyst because of its poor ability to adsorb. बेरियम सल्फेट क्या करेगा? सरफेस को इंप्योर कर देगा. 2. Surface area. This is very important. Larger the surface, greater the adsorption. Larger surfaces, therefore, finely divided substances adsorb more. So all these catalysts are taken in spherical balls like this. Small spheres, sphere will have a larger surface, 4 pi r square. And Raney nickel, what is Raney nickel? Finely divided, powdered nickel, finely divided spheres of nickel. It's a good adsorbent. Why do transition metals act as catalysts? They have large surfaces. They are malleable and ductile. They can be converted to sheets. Third point. Greater the critical temperature, more is the ability to adsorb. Critical temperature, intermolecular forces. Intermolecular forces, boiling point, the other day I told you, the 7 points, boiling point, critical temperature, ease of liquefaction, ease of adsorption. Intermolecular forces. Pressure. X by M is proportional to P power 1 by N, where N is not equal to 0. This is Freundlich adsorption equation. What is X? Mass of adsorbate. M, mass of adsorbent. Mass of adsorbent. Certain mass of an adsorbent, coconut charcoal, 100 gram, adsorbing 1 gram noble gas. P is pressure, and X by M is equal to K into P power 1 by N. K is of course a constant. Pressure X by M. How will you get the curve? How does the graph look like? So, beyond a point, we reach a plateau. Beyond a point, no further increase. मतलब एक हद के ऊपर जितना भी प्रेशर डालो, एड्सॉर्प्शन में कोई फर्क नहीं आने वाला. Log X by M is equal to 1 by N log P plus log K. This is Freundlich adsorption isotherm drawn at constant temperature. डिपेंड नहीं करता है ना. मास ऑफ द एब्जॉर्ब के ऊपर डिपेंड नहीं करता है. कितना एब्जॉर्ब हुआ प्रेशर के ऊपर डिपेंड करता है. नहीं, जो दिस इज कॉल्ड कोएफिशिएंट ऑफ एड्सॉर्प्शन, डिग्री ऑफ एड्सॉर्प्शन. कितना एड्सॉर्ब हुआ डिपेंड्स ऑन प्रेशर.
मैं बोल रहा हूँ कि वो नीचे मास ऑफ एड्सॉर्बेंट है ना, मतलब जिस पे एड्सॉर्ब हुआ है तो वो तो कितना भी हो सकता है, लेकिन फाइनली सिर्फ सरफेस पे डिपेंड करना है.
दैट यू आर राइट. It should not depend on mass, it should depend on surface. But this is how that is calculated. इसको ऐसा ही कैलकुलेट करते हैं. log x by m log p क्या होगा? You get a straight line. Means suppose we compare different masses. You prepare whatever surface you like. This is the maximum that is adsorbed. The ability of the adsorbent. This is log k, and slope of the curve is equal to log 1 by n. Freundlich adsorption isotherm सिलेबस में नहीं है. किसका? एडवांस का सिलेबस में नहीं, मेंस में है. लेकिन जब एनसीईआरटी में है तो सब में होगा. लॉन्गमोर adsorption इक्वेशन लगता है एनसीईआरटी में भी नहीं है. x by m is equal to bp upon 1 plus ap. bp by 1 plus ap, where a and b are constants, no relation to van der Waals, and they are different for different adsorbates. Generally solids only adsorb, generally gases only get adsorbed. Gases and solids. Now, x by m is equal to, at high pressure क्या होता है? High pressure Bp by, this one can be neglected, Ap is equal to B by A, constant. So beyond a pressure, pressure has no impact on adsorption, extent of adsorption. And when A is equal to 0, x by m is equal to Bp, B into P power 1, B being a constant, this is Freundlich. So, Freundlich is the general equation in which Longmore is a case. It's like y is equal to mx plus c is the general equation. Y is equal to mx is only a case of that, when c is equal to 0. General equation and its case. So, Longmore is the general, Freundlich is the general, and Longmore is a case of this one. हाँ कैसे? नहीं? अच्छा हाँ ठीक है. Longmore is the general equation in which Freundlich is a case. Longmore में अगर A is equal to 0 रहा तो Freundlich आएगा. कल छुट्टी मार दिया सब लोग. आज भी नहीं है ना बाकी लोग. दिवाली now types of adsorption. Adsorption is of two varieties. Physical, physisorption, also called physisorption. Chemisorption. One. Weak van der Waals force. Physical adsorption, it is weak van der Waals in nature. Chemisorption, strong chemical bonds are formed. Stronger. I won't say strong, stronger than physical. Stronger chemical bonds are formed. How? With residual valencies. What are residual valencies? Let us see. Let us take a nickel surface. So, those who are in the bulk, look at this nickel. It has 4 bonds, and those which are on the surface, they have only 2 bonds. Therefore, these are called residual valencies. When hydrogen comes, they will attract hydrogen. Anybody. So, during the hydrogenation of oils, alkenes, H2Ni, क्या करेगा? निकेल सरफेस हाइड्रोजन को और इथिलीन को एब्जॉर्ब करेगा. Since they are present more on the surface, since their concentration is more, the likeliness of collisions will increase. More collisions will take place and rate of reaction increases. What is the role of a catalyst? Only to increase the rate of reaction. Therefore, catalysis is also a surface phenomenon. 2. Enthalpy of adsorption is less. Kitna I am not exactly sure. 20-25 kilojoules कुछ तो होगा. हाँ? Enthalpy of adsorption is more. Less than 25 होगा इधर. Is more, and this one is specific. No, not specific. वो कैसे? कोई भी किसी को भी physically absorb कर सकता है, because there is van der Waals. Anyone can absorb anybody, and you can never expect chemical bonds to be formed with helium, na? Helium, if absorbed by somebody, it is just physical adsorption. It can never be chemical. So, this is specific. Because for bond formation, you have to specific. What do you mean by not specific? Anyone can absorb anyone. And this is multi-layered. This is unilayered. How? Suppose here is a surface. Somebody is absorbed. And the adsorbate will now become a part of the adsorbent. ये दोनों एक बन गए. अभी एक और लेयर है तो उसको भी van der Waals attraction है. Van der Waals. And in fact, that goes on increasing, the van der Waals attraction. But here chemical bond has to be formed, and you cannot have another layer. You can't expect another hydrogen to be here. What was the question you were asking me yesterday? Carbon monoxide में central atom कौन है? The question of central atom comes only when we have more than two atoms. नहीं, ज्यादा मतलब दो से ज्यादा रहा तो ही सेंट्रल बात होता है. दो लोगों के बीच में सेंटर क्या है? And this is reversible. This is not reversible. Yes? Once broken, cannot be formed easily, not reversible. Make a note. सेंट्रल एटम का नेचुरली दोनों का लिखो +2 -2 कौन माना करेगा? Now, adsorption. आधा घंटा का लेसन है, इसको इग्नोर नहीं करने का. बोर्ड में डेफिनेटली ये पूछते डिफरेंसेस बिटवीन फिजिकल केमिकल एडसॉर्प्शन. एक कब था हमारा बीएससी फाइनल ईयर में था. They used to ask, prove that Langmuir is a general equation and Friendlich is a case. So हमको दोनों इक्वेशन लिखना है, बस this is a case करके लिखना है. When A is equal to 0. And this topic, surface chemistry, is the new age chemistry. Why? सारे बॉन्डिंग हो गए अभी. अभी क्या सिर्फ अट्रैक्शन के साथ बताना है. ऑल टाइप्स ऑफ बॉन्ड्स, ऑल टाइप्स ऑफ कंपाउंड्स आर डिस्कवर्ड. सो दिस इज अ न्यू एज केमिस्ट्री. नाउ effect of temperature and adsorption. This is very, very, very important. Effect of temperature on adsorption. Both type of adsorptions, physical and chemical, depend on pressure, directly proportional to pressure. Both varieties. But temperature, physical adsorption, x by m on x-axis, y-axis, temperature, decreases with increase in temperature. X by m decreases with increase in temperature. What about chemical adsorption? Yeah. Chemical first increases to a point and then decreases. This is adsorption. Desorption. Why does it increase initially? Activation energy is supplied, EA. Activation energy is supplied to start with. And why does it break at higher temperature? Sorry? All bonds break beyond a point. All chemical bonds dissociate, na? Except FH and OH bonds. Effect of temperature on adsorption. Adsorption from solutions. Adsorption from solutions. Two questions were asked in the past on this. 2015 mains में था, तो 2003 advance में था. A solution of acetic acid charcoal bed, acetic acid. How to decrease the concentration without adding any solvent? इसमें पानी नहीं डालने का, लेकिन concentration decrease करना है. Adsorbent डालो, which adsorbs acetic acid molecules, catches hold. सर वो adsorb हो गया, लेकिन फिर भी solution का अंदर ही है ना. But they are not moving. What is the most important quality for solute particle? It's random motion. It should be moving. Here it is a solid, it's a part of the solid. Charcoal का भाग बन गया. So, 0.125 ml, 125 ml, 2003 का क्वेश्चन. वो मोल कंसेप्ट में दिया, देखो मोल कंसेप्ट का लास्ट क्वेश्चन. खोलो यार, मोल कंसेप्ट का सब्जेक्टिव का लास्ट. लास्ट but one. Two 2003. Read the question, data.
In a solution of 100 ml, 0.5 molar acetic acid.
100 ml?
0.5 molar acetic acid.
Just a minute. 100 ml, 0.5 molar acetic acid.
1 gram of active charcoal is added.
Yes.
Which absorbs acetic acid. It is found that the concentration of acetic acid becomes 0.49 molar.
अच्छा, 0.49 molar. 100 ml, 0.59 after adsorption.
If the surface area of charcoal is 3.01 into 10 power 2 meters square, calculate the area occupied by single acetic acid molecule.
Yeah, calculate the area occupied by each acetic acid molecule. Come on. So to start with, how much you have? 100 into 0.5? 50 millimole. Yeah, 50 millimole and 49 millimole. So 1 millimole has been adsorbed, and that 1 millimole is occupying 3.01 into 10 square. So each kitna? This upon 6.023 into 10 power 20 millimole. So this is the total area available and this is the number of people who are sitting on that area. Each will get 3.01, 6.0, very funny, 1 by 2, 0.5 into 10 power minus 18, 5 into 10 power minus 19 square meters. 5 into 10 power minus 19 square meters. Look here, when this was given in 2003, I predicted the next year's question. You also can predict. And that is there in 2005. So, it is adsorption from the solution. If it is applied to gases, what will happen? What happens when a gas is adsorbed? Which factor will change? Pressure. Bus. Next year the same question is going. Change in pressure. So, as I told you, IIT questions evolve over a period of time. No new questions are created. They are evolved. Last year के value addition करते. One step ahead. Now, so कितना pressure decrease हुआ, change in pressure वगैरह दिया, and whatever is asked in the next year's question. And X by M is proportional to from a solution, proportional to anybody. Huh? X by M is proportional to? Very good. C power 1 by N. Solute, look here. Gas molecule is to a gas, whatever is as, gas molecule to a gas is as solute particle to a solution, solute particle to a solution. Similarly, pressure is to a gas. Pressure is to a gas. What? Concentration is to a solution, mind you. Whatever is pressure to a gas, the same. I told you gas molecule and solute particle are one and the same. Define a gas molecule. Define a gas molecule. Someone moving freely in air. And solute particle? In a solvent. Somebody moving molecule, particle moving freely in a solvent. Pressure is to a gas. What concentration is to a solution? Bachpan ne kiya hoga na ise? Delhi is to India. What Islamabad is to Pakistan? Yes, yes. What is the capital of Andhra Pradesh? Huh? Aurangabad. Aurangabad. Aurangabad, Nanded, Parbhani. Huh? Amravati. Amravati, the new capital. Amravati is to Andhra Pradesh. What? Mumbai is to Maharashtra. Amravati. Huh? है ना अमरावती नागपुर के पास है ना बदनेरा. The new capital is named after Amravati. Now, right, and applications of adsorption. Applications of adsorption is a very interesting area. Very really. Adsorption has many applications. Hello. Froth flotation, who is adsorbing who? Froth flotation. The oil is adsorbed by PVS, lead sulfide. More covalent one will adsorb. Froth flotation. And separation of noble gases. What do you mean by separation of noble gases? Look here. What does air contain? Air. N2 with the major constituent O2, CO2, moisture apart from noble gases. I don't know their percentage. I think it is 1/1000%. Helium, neon. Helium nahi hai. Normal air mein nahi hai. Anyhow, helium, neon, argon, krypton, xenon, radon, all of them are there. Helium and radon are not present in this room. Helium and radon. Helium being the lightest gas, it is in the uppermost environment, and radon being a product of radioactive disintegration, it is there only in uranium mines. क्या करेंगे इसको? Heat that with magnesium. What happens? Magnesium nitride. And treat that with copper, cupric oxide. Treat that with alkali. They absorb, not adsorb, AB. Absorb CO2. And you know, concentrated H2SO4 absorbs moisture. Huh? Noble gases. Moisture. Now, what is it you have got as a result? After all this, you have got noble gases. This is called separation of noble gases. Isolation. Isolation of noble gases. Noble gases have been isolated as a group. What is the isolation of noble gases? Air to mixture of noble gases. And now, if you individual noble gases are, this is called separation. Individual noble gases, separation. Separation means all five are given in 5 different containers. Coconut charcoal, 1. You have helium, neon, argon, krypton, xenon. Okay. 5 noble gases. Coconut charcoal 1. This will absorb argon, krypton, xenon. Argon, krypton, xenon. So what are separated by now? Helium and neon are present in the container. After case 1, result argon, krypton, xenon on the container, helium, neon in the room. Now, you take coconut charcoal 2. Coconut charcoal 2 इन तीनों में से 2 को एब्जॉर्ब कर देगा. Which 2 are absorbed and which is not absorbed? Argon, krypton are absorbed and xenon is not absorbed. Xenon इधर ही रह जाएगा. Xenon is strongly absorbed, no? Bigger in size, mass ज्यादा है. हाँ, xenon strong अंदर नहीं जाएगा. Don't mistake me. Xenon being strongly absorbed. Thank you. Happy Diwali. This is my 3rd consecutive Diwali here. I asked my wife to come over here, but she was held up because her mother is not well. My God. 46 days total I stayed in Pune, but I have never been to any part of Pune. I don't know what are the Dagdu She क्या है वो गणपति मंदिर सामने से गया बस ऐसे ही सुनील लेके गया 3 आर्गन क्रिप्टॉन ये देखो सेकंड चारकोल देखो लेस एडजॉर्बर को खींचेगा लेस एडजॉर्ब व्हाट डू यू मीन बाय लेस एडजॉर्ब व्हाट डू यू मीन बाय लेस एडजॉर्ब वीक एडजॉर्प्शन आर्गन एंड क्रिप्टॉन और नॉट एडजॉर्ब कोकोनट चारकोल 3 क्या करेगा देखो इसको अगर हीट करो हीट किया तो एक इसके ऊपर रह जाएगा कौन क्रिप्टॉन रह जाएगा आर्गन बाहर है बस डिसॉर्प्शन वीकली एडजॉर्ब एट ए डिफरेंट टेम्परेचर ऑल दीज आर डन एट -180 वो टेम्परेचर में करते नाउ हीलियम नियॉन कोकोनट चारकोल 3 क्या करेगा हीलियम और नियॉन को खींचेगा सो नियॉन इज इन चारकोल 3 हीलियम इज इन द ओरिजिनल कंटेनर हीलियम को कोई एब्जॉर्ब नहीं कर पाएगा हीलियम ओरिजिनल कंटेनर में है नियॉन थर्ड में आ गया आर्गन सेपरेट हो गया सेकंड वाले में xenon रह गया ना xenon is in 1 ये 1 है ना 1 you have to take 3 charcoals 3 different ones say 3 लेना है तुमको सेम रहेंगे लेकिन एट ए पर्टिकुलर टेम्परेचर ओनली 1 विल बी एब्जॉर्ब इज डायरेक्ट फ्रॉम टेम्परेचर नो ये दूसरा चारकोल है ना पहला चारकोल में जो लेस एब्जॉर्ब उसको खींच लेगा हाँ दैट इज कॉल्ड एल्यूएशन एल्यूएंट हाँ दैट इज व्हाई xenon remains with the first charcoal until the last when heated the less adsorbed will get desorbed मैंने ललित सर को तुम्हारा बहुत तारीफ किया है ये बैच अच्छा है पिछले बार से कंपैरिजन में लेकिन पेशेंस नहीं है ताकत नहीं आधा लोग ये भाई पिछली बार 120 बचे हैं दिवाली के दिन हाँ इनऑर्गेनिक हो गया अगली दिवाली को क्या होगा नेक्स्ट ईयर आई एम हियर फुल टाइम हफ्ते में 3-4 दिन इधर ही हूं हफ्ते में 3-4 दिन आ जाऊंगा इससे ज्यादा परमानेंट कैसे हाँ नहीं घर तो नासिक में रहेगा इधर होटल या तो इधर भी एक रेंटल अकोमोडेशन लूंगा अभी फालतू में 1500 पर डे. Now, please, noble gas, noble gases don't form any compounds. Noble gases don't form any compounds. अगर only fluorine and oxygen form compounds. Only fluorine and oxygen form compounds. And only fluorine on direct combination. Xenon plus fluorine, XeF2. Xenon plus oxygen, nothing will happen. No action. Oxygen compounds are formed indirectly. Oxygen compounds are formed on the hydrolysis of fluorides. Xenon fluorides. Other noble gases form cage-like compounds. Cage-like compounds. Very good. कहाँ पढ़ा? NCERT में है क्या? Cage-like compounds called clathrates, where noble gases are trapped in, they are trapped in a frozen solution of beta quinol. Beta quinol is a liquid. These noble gases are trapped, and helium and neon do not form even clathrates because they are very small. They are very small and they cannot be trapped. इतना छोटा मच्छर के लिए मस्कीटो नेट भी काम नहीं करता. नेट से भी बाहर आ जाती है. So helium and neon do not even form clathrates. Xe? Hydrolysis of XeF6. कौन सा? That XeO3 will undergo disproportionation. Xe and XeO4. इसलिए मैंने हाइड्रोलिसिस ऑफ xenon fluorides एनसीईआरटी से पढ़ो. जेडी ली इनका प्रीफेस में ये लिखता है, ए टेक्स्ट बुक 1961 it was discovered that noble gases form compounds. No doubt noble gases form compounds. But the excitement died down within 2-3 years. Why? Okay, they form compounds, but what is their utility? बोले कि क्या करेंगे, सिर के मारेगा क्या? Compound should have any use in daily life. उनका कोई use है ही नहीं. Noble gas compounds form करेगा तो क्या, नहीं करेगा तो क्या, कोई फर्क नहीं पड़ने वाला. So a textbook which gives more details of noble gases than the manufacture of sulfuric acid, he says, I consider that as a bad book. J.D. Lee का preface पढ़ना है, last paragraph. Large amount of chemistry is very easy. These are his words. Large amount of chemistry is very easy, but some part is enormously difficult. Some part is enormously difficult. क्या बोला उन्होंने? I beg to. शेड्यूल है क्या? नहीं. So I tell my fellow fools. I beg to. He used some good phrase there. I tell my fellow fools that master these thoroughly, the rest will follow. These means some part is, large amount of chemistry is very easy. Large amount of chemistry is very easy. Some part is enormously difficult. So, oh my God, how can I forget that? Is there my website also? So, he says, these are not my words, these are the words of Professor Sylvanus P. Thompson, the famous Sylvanus theorem in calculus. In his book Calculus Made Easy, he said, I beg to propose to my fellow fools, master these thoroughly, the rest will follow. What one fool can do, another can. He is saying, fellow fools, I am also a fool. What one fool can do, जैसा मैंने सीख लिया तो भी सीख सकते हो. Master these thoroughly. है ना? जो easy है ना, large amount of chemistry is very easy. Don't go over the enormously difficult part. Enormously difficult part. The disproportionation reactions, the unpredictable phenomena. Don't go after that. So part 1 of surface chemistry is over. Adsorption from solution. And more examples, yes. Hello. Vegetable oils. Fuller's earth. Fuller's earth. Ever heard of this? Fuller's earth is made of China clay. In the olden days, vegetable oils contain poisonous pigments. Vegetable oils, they contain poisonous pigments. It's like the root of a groundnut, the root is poisonous. So when they are thrown on this, when they are made to slide on this, flow on this Fuller's earth, the poisonous pigments are absorbed from vegetable oils. Even today in villages, this where oil is manufactured, this is their Fuller's earth. China clay, made of China clay, is a good adsorbent. Froth flotation, isolation of noble gases. Where else is adsorption is important? Creating vacuums. How can you create a vacuum? Vacuum means perfectly pressure 0. You can adsorb everybody, but how to remove noble gases? Only by using coconut charcoal and adsorption principle. Creating vacuum. So that's all. Colloids. Colloid. Any question on colloid, think in terms of particle size. Already told you, na? What is a colloid? The particle size ranging from colloid 1 micron to 1 millimicron. 1 micron to 1 millimicron. Particle size ranging from. Methods of preparation. What is the functional definition of a colloid? Functional definition. Two substances are there. I know, but I can't do anything to separate them. What about a true solution? We don't even know that there are two substances. Do you know in our drinking water, at least 100 salts are there. The water we drink, 100 salts are there. And indeed we need them also. We don't need H2O for the body. Do we need H2O? No. Why? That is produced during the combustion of food. Food जो हम खाते हैं ना, CO2, H2O ही तो आता है. We don't need H2O for the body. We only want the minerals, the dissolved salts. And all water we drink is mineral water. Mineral water is not just what we buy for 20 rupees a bottle. जो जमीन से नीचे मिलता है, that is mineral water. H2O. Now, methods of preparation. Distilled water में कुछ नहीं रहता है, कुछ नहीं रहना है. Suppose to give an injection, you have to use 100% water. Why? So, if you use normal water, what will happen? The medicine will hydrolyze. Organic compounds are prone for hydrolysis, na? इसका अंदर H plus वगैरह रहा तो, if you take aspirin injection, acetyl salicylic acid, OCOCH3, aspirin. What will happen? If you add aspirin to normal water, that will become salicylic acid and acetic acid. 2 acids, bonus. 2 acids, the ester will give you 2 acids. That is why aspirin creates ulcers, in the sense acidity if taken on empty stomach. It is not advised to on an empty stomach. Now, that is called a demineralized water. Demineralized water, distilled water as well. Even in a laboratory, if you use normal water, you get wrong results. And why do we store rainwater? Actually, during rainy season, the laboratories we store rainwater store करते. Or maybe to dissolve substances, rainwater is used, which contains minerals. Now, rainwater is not pure water. It contains nitrous acid, carbonic acid, sulfurous acid if you are lucky. अगर ऊपर जमीन में सल्फर डाइऑक्साइड इंडस्ट्री है तो सल्फर डाइऑक्साइड रहेगा. सल्फर ट्राइऑक्साइड रहा तो very hazardous. Now, 1. Dispersion methods. Functional definition of a colloid. Functional definition. उधर खाली है ना, उधर बैठ सकते हैं. यहाँ बैठ के क्या दिखेगी? बेवकूफ. Sitting parallel to me, can you see anything? Dispersion techniques. Paints are manufactured using this technique. Paints. Yes, give me the functional definition of colloid. 2 phases are there, 2 substances are there, but we cannot separate them easily. We know. Milk, we know that there are more than one substance. But ask me to separate, you cannot easily. Suspension? Oh, that is not called easy, na? Separating easily nahi hai na wo. Paneer. So, what about suspension? दूसरा सब्सटेंस दिखेगा, हम चम्मच उठा के उठा सकते हैं. अगर थोड़ा मिट्टी है, धूल है, तो यू कैन टेक अ स्पून एंड इजीली रिमूव दैट. ठीक है ना? वेरी इजीली. फिल्ट्रेशन में हो जाता है. फिल्ट्रेशन में हो जाता है सस्पेंशन. अल्ट्रा फिल्ट्रेशन में हो जाता है कोलॉइड. अल्ट्रा फिल्टर्स कैन बी यूज्ड टू सेपरेट पार्च्ड मेम्ब्रेन वगैरह, टू सेपरेट कोलॉइड्स. नो फिल्ट्रेशन इज कैन बी डन फॉर सॉल्यूशंस. सॉल्यूशन के लिए कुछ भी नहीं चलेगा. डिस्पर्शन मेथड्स. यू हैव टू रोटेटिंग डिस्क्स. एक डिस्क है ना, इसके ऊपर एक और डिस्क रहेगा. तुमको मालूम है ना वो पत्थर कैसे रहता है आटा बनाने का? ग्राइंडर. व्हाट इज दैट? चक्की. राख, पत्थर की चक्की. ठीक है ना? है क्या किसी के घर में? नाउ, सो द मटीरियल, the paint dyestuffs are kept between the two discs, and it is sent directly into hot turpentine oil. Yeah. And molecules, colloidal size, enter with kinetic energy. That is important. What are we providing by rotating the disc? Kinetic energy. They are going into the hot turpentine oil and they start dispersing. What is the word we have to use? Disperse. My maternal uncle had a paint industry. We used to do this. But they were ball mills. Ball mills रहता था. Rotating, not discs, but rotating rollers. दोनों के बीच में से क्रश हो क्या था. देखो, types of colloids. Depending on, देखो, depending on methods of preparation 3-4 और है, बाद में देखेंगे. Depending on the dispersion medium. dP in dm, dispersed phase in dispersion medium. It is comparable to children in a playground. The stationary one, playground. बच्चे ग्राउंड में खेलते हैं ना, ग्राउंड तो कांस्टेंट रहेगा. ग्राउंड विल बी कांस्टेंट, बट द चिल्ड्रन विल बी मूविंग. दे आर द डिस्पर्स्ड फेज, द फेज which is moving. Stationary versus opposite of stationary, moving. Now, depending on the dispersion medium, colloids are classified as hydrosols or aquasols. What is that? Water is the DM, H2O is the DM, dispersion medium. Aerosols. Aerosols. What is an aerosol? Air is DM. Alcosols. Alcohol is a dispersion medium. You should know that most of the allopathic syrups are alcosols. They are alcohol based because they are not soluble in water and they have to be given directly. So they are dissolved in alcohol, alcosols. And even some of the homeopathic medicines are also alcohol based. There is something called gripe water. Gripe water, ever heard of that? Gripe water. छोटे बच्चों को दिया जाता है इंडाइजेशन अगर हुआ तो. That is nothing but 1% वॉल्यूम पे वॉल्यूम ऑल खा. तो 2 बूंद भी है तो बच्चे सो जाएंगे आराम से. इसलिए दादी बोलती है बच्चा क्यों रो रहा है, मैं भी तो वही देता था बचपन में तुम्हारा, ग्रेप वाटर दे दो. Now, grandmother tells daughter, daughter tells her daughter like that. Now, depending on DP and DM, colloids are classified as solid in solid colloids. What is that? There are 2 solids. We know that and we cannot do anything to separate them. Examples? Gems, precious stones. Precious stones. The other part is visible also, but we cannot separate them easily. Amalgam or alloys of mercury. Anybody with mercury is called an amalgam. Amalgam is not a colloid. Amalgam is a solution. Amalgam is a solution. Alloys are no colloids. Alloys are not colloids. You look here, this is an alloy. Alloy of perhaps nickel, chromium, iron. Show me where is nickel. Nickel का है, chromium का है. ये nickel है, ये chromium. You cannot single out. You cannot single out. Solid in solid. Solid in liquid. Starch in water. Starch sol. Starch sol. Gold sol. Solid in liquid. Gold sol. Why are gold sols prepared? No. Why are gold sols prepared? Arey gold sol. They are medicines for some skin diseases, dermatologically. Solid in liquid. Solid in gas. Yes? Solid in gas. Solid in gas. Smoke. What is smoke? Carbon particles in a mixture of gases. Carbon particles in a mixture of gases. Next. Liquid in liquid. Surface chemistry, you get only 1 question at the advanced level. Mains में वो भी भरोसा नहीं. ऐसा कोई प्रॉब्लम की जैसा आएगा. हाँ, मेंस में भी एक क्वेश्चन आएगा. Liquid in liquid, yes. This is called emulsion. Liquid in solid to start with. Liquid in solid. Yes, they are called gels. Butter. What is butter? Butter. Amul ho ya kuch aur ho, butter. You know, there is solid mein liquid hai. And what else are gels? Butter. Huh? Boot polish. Boot polish, huh? Turpentine. Cheese is semi-solid. Boot polish. Turpentine oil in Bismarck brown. Bismarck brown is a powder, dye. Bismarck brown ka andar turpentine oil. Liquid in liquid. It's called emulsion. Milk. What is blood? Blood kya hai? Solid in liquid. Blood. What are the solids? Red blood cells, white blood cells, platelets, वगैरह in water. Liquid in gas. Liquid in gas. Liquid in gas. Fog. Mist, fog. Not the perfume. Fog. The winter fog. Since yesterday we had the coldest day, 12.4 temperature, kal subah. Nasik mein 11.2. Now, liquid in gas. Then, gas in solid. Example, occluded hydrogen. H2 in palladium. Occluded hydrogen. Gas in liquid. Gas in liquid. Aerated waters. Aerated waters. Aerated beverages. Aerated beverages. The cool drinks वगैरह. Carbon dioxide. Water. The fizziness is because of carbon dioxide. Cloth rates, you can say solid in liquid. Gas in liquid. Gas in liquid. To start with, beta-quinol was a liquid, na? It is frozen. You can say gas in solid bhi bol sakte hain. Cloth rate. What about gas in gas? They are not. No, they are not colloids. They are not colloids. Gas in gas is not a colloid because mixture of gases. Mixture of gases, you can never identify that there are more than two gases. Even if one of them is colored, the entire mixture will take the same color. Suppose if two of them are colored, you get a mixture of the colors. So you can never identify. Okay, let's take a break. Band kara.
Solid